All right, good morning, guys. You're going to be watching this lesson in just a few minutes. I recorded it last night, and the audio was screwbally, so this is the second try. Today's lesson is all about parallel and perpendicular lines. And we're going to talk about what that means and what it means in relations to the equation of a line in the form y equals mx plus b. So let's get going. Parallel lines are lines that never meet one another, even if they're extended all the way out to infinity. So if these lines go on forever and ever and ever, they'll never meet. And I hope you see that looking down at these two examples here, we would say that these two on the left are not parallel because they meet, and that the two on the right are parallel. They never meet. So what I want to do is start looking at the equation of these lines and see if we can compare them. So take a minute and see if you can find the equation of these two lines. All right, I'll assume you've paused the video. So we're going to look at this one here. This has a positive slope. It has a rise of 1, a run of 2, and it has a b value of 1, just like that. So if we wanted to make an equation for that red line, we could say, okay, well, y equals the slope. The slope is rise over run. So in this case, 1 over 2, and that's positive. So 1 over 2x, and then the b is 1, so plus 1. For the blue line, we would say this has a b of negative 2. And we'd make our triangle here like this. We'd say that's a run of 3, a rise of 2. And so for the blue line, we would say y equals rise over run, 2 over 3. This one is going down, so it's a negative slope, negative 2 over 3. And x and plus b, in this case, b is negative 2, so we'll say minus 2. Y is negative 2 over 3x minus 2. And we don't see much connection in those two. Let's take a look at the lines on the right. In this case, the parallel lines, the red line has a b of positive 2. And it has a run of 3, a rise of 1, and it's a negative slope. So altogether, we would look at that line and we would say it has an equation of y equals negative 1 over 3x plus 2. And if we look at the blue line, and if we make a nice triangle for it, we would say it has a rise of 1 and a run of 3. When we made that equation, we would say y equals negative 1 over 3, negative because the line's descending, x plus, what's b in this case? Negative 1 minus 1. And I'm hoping, in fact, I know that right now Shayla's in the back saying, I see it, I see it, I see it. And if you look here, these have the same slope. The parallel lines, the lines that go on forever without meeting, have the same slope. Whereas if we look over here, we don't have the same slope. We in fact have different slopes. And that's the rule, in fact. Two lines are parallel if they have the same slope, because then they will rise and run by the same amount forever and never meet. And they're not parallel if the slopes are different, because at some point they will meet. So we're going to do a couple examples here. First one just says, write the equation of two lines that are parallel to this one. So take a minute, see if you can try that. If not, we'll do it together. And we're back. The trick here, of course, is we need to know the slope, because parallel lines have the same slope. So we need to know m. And to do that, we need to put this in slope-intercept form. We need to put it in slope-intercept form, which of course we know is y equals mx plus b. So we have to solve this for y. Hopefully that's enough of a hint for you if you needed it. Pause the video and come back. I'll assume you're back now. I'm going to start with 5x plus 3y minus 6 equals 0, exactly what we had above. And let's say, Caitlin, what should I be doing? And she's going to say, well, we want to get rid of this 5x. So we'll subtract 5x. If we're going to do that to one side, we have to do it to the other. She's going to say that we also want to get rid of that 6. And the opposite of negative 6 is adding 6. What do I do to one side? I have to do to the other. When that's done, we're left with what? And Nathan is saying we're left with 3y equals negative 5x plus 6. He is, of course, right. And he is telling me now that what we need to do now is divide this side by 3. And what we're going to remember is that multiplication and division are both distributive, which means that we're going to divide the 6 by 3 and the 5x by 3. They both have to be divided. So we're going to put a divide by 3 here and a divide by 3 here. It's very important. Multiplication and division are both distributive processes. And now we can work this out. 3y divided by 3. Well, that leaves us just with y. Negative 5 over 3, leave that as a fraction. Yes, you could make it a decimal. It would be negative 1.667. But fractions are your friend because they give you a rise over run. So negative 5 over 3x. And then this doesn't need to stay a fraction. 6 divided by 3, of course, is 2. And there we go. Now that means that this here is the slope in question. This is m, the slope. And our new lines, parallel lines, will have the same slope. So they're going to have the same m value, and they can have whatever b value you want. You can make any b up that you like. So I'm going to make 2 up. Y equals negative 5 over 3x plus 4. And I'm going to say y equals, shouldn't have it next. Yeah, okay, 1 second. See, I can do this, you can't. Maybe I can't either, who knows? There we are. I'm also going to say y equals negative 5 over 3x minus 2. And what I want to show you is that all 3 of these, since they have the same slope, will be parallel. They'll just start at different levels on the axes. So if we come in here and we go to Desmos, the original was plus 2, yeah. So we can say y equals negative 5 over 3x plus 2. There's our original line. Nice looking line. The next one I can say y equals negative 5 over 3x. Oh, whoops. Plus 4, that was my next one, I think. Yeah, I did plus 4 and minus 2. And so y equals negative 5 over 3 x minus 2. And there they all are. 3 parallel lines. The red one is the original. The blue and the green are the new ones. They have different y-intercepts. So all 3 have different y-intercepts, 4, 2, and negative 2, which we find here, but they have the same slope, so they're parallel. Let's try this question on the right here. Write the equation of a line parallel to y equals 1/3 x minus 5 that passes to the point 6,1. So pause the video, see if you can do that yourself. Y equals, was it? 1/3 x minus 5. 1/3 x minus 5. So here we go. Here's our original line. You'll see that this does not pass through the point 6,1. So the original line isn't the one, but a parallel line can. So the trick to this is to know, just like last time, the parallel line will have the same slope. So it has the same m value, same slope, but a different b. So we're going to write this out. I'm just going to say that y equals mx plus b will be our new line. And then let's put what we know in. Well, we know that the slope, m, is going to be the same. It's going to be 1 over 3. We don't know b, though. We're going to have to find b. And to do that, we're going to use the point we've been given. We know that that 6 is the, thank you, Sammy Sparks, that's the x value. And the 1 here, that is Lane Gelka. Correct, that's the y value. Oh. So the only thing we're left with that we don't know in this equation is b. So let's put them in. We can say that y value of 1 is equal to the slope, which has to be a third. So it's going to be parallel to that original line. The x value in this case is 6. And then plus b. And now we can just solve this. What is 1/3 times 6? Well, maybe you can do it in your calculator. Maybe you can do it in your head. 1 times 6 is 6. Divided by 3 is 2. That's going to be 2 plus b, like that. And now what do I have to do to solve this? And Jazz, of course, is saying, well, we got to get rid of that 2. I'm going to ask her how, and she's going to say, well, you have to subtract 2. And I'm going to subtract 1 from this side. And then Shayla's going to scream at me, and she's just going to leave. She's just going to leave class and be done with it. But the reason is she knows that what we do to one side, we must do the same to the other. So we subtract 2. 1 minus 2 is negative 1. And over on the right side, we only have b remaining. And once we know b, we know our new equation. So we can say the line y equals 1/3 x minus 1 passes through the point 6,1. Just like that. And in fact, we'll show that here. Y equals negative 1/3. Oh, not negative. Y equals 1/3 x minus 1. And if we look, lo and behold, that passes through the point 6,1, just like it's supposed to. In fact, I can put it here, just to show you. There it is. All right, so that's about parallel lines. Lines are parallel when they have the same slope. Next, I'm going to have protractors passed out to you. So if they haven't already, those protractors on the front cart, the cart where my computer is, make sure everyone gets a protractor. And let's look at this. Two lines are perpendicular if they meet at 90 degrees to one another. So I want to look at an example. We're going to start by graphing the line y equals 2/3 x plus 0. So no y-intercept, but a slope of 2 over 3. So the y-intercept's right at 0. We can put that on. And the slope is 2 over 3, so that's a rise of 2 and a run of 3. We got our next point, rise of 2, run of 3 if we want another point. 2 and 3 if we want yet another point. We can go down 2 and over 3, however many you want. But I want this one to be done really carefully. So I'm going to put a few of these on here, just like that. And I'm going to do my best to draw a really straight line. Now, I, of course, have an advantage in that I can just draw a really straight line. But I want you to do your best to do the same. So there is my really straight line. And what I want you to do now is use your protractor to make a line perpendicular to that. And I want to go through the same origin. So I want you to put kind of the little crosshairs of your protractor right there, right like that, so that it looks, you know, something like this. This would be 0 over here, and 180 over there. We'll call that 45, and 30, and 60, and 90, and so on and so forth. And we, of course, want to make sure we draw a line exactly at 90 degrees. We're going to put a big point there and draw a line through it. Now, mine, of course, was obviously not the greatest. But here we go. I'm going to go, give me just a sec. 2 over 3, right? Oh, gosh. Okay, I'm going to draw my parallel line, just like that. No, it's just a little too heavy a line for me. Let's try this one instead. Okay, so here's our perpendicular line. And we know it's perpendicular because we drew it at 90 degrees. By the way, this should be obvious, but you don't have to draw the protractor. I drew it on because I don't have a real protractor here. What I want you to do is find the equation of this line. When we do, we're going to see that e is equal to 0. And the slope, well, the slope has a rise of 3, and a run of 2. And it's negative, right? It's decreasing this line. So the slope of my perpendicular line would be negative 3 over 2. And the original line had a slope of 2 over 3. Now this one's tougher to see, but hopefully you see the pattern here. These are what we call negative reciprocals of one another, which means that where one is positive, the other is negative, and the fractions are flipped. So negative 3 over 2 became positive 2 over 3. All right, so we flip the fraction. And we switch the sign. Let's do an example. If the original slope was 5 over 7, the perpendicular slope would be, and that's right, it's negative 7 over 5. Very good. So now let's just do a couple of questions like that. Remember, we have perpendicular lines if the slopes are negative reciprocals. So if we flip that fraction and we switch the sign. So first we're going to write the equation of two lines that would be perpendicular to this line. And you can go ahead and do that. Pause the video. And we're back. The trick to this one, of course, is that the original slope, if the old slope is 3 over 2, the new slope, the slope of our new lines, is going to be the negative reciprocal of that. That's how you make perpendicular lines. So we have to flip the fraction, which would make it 2 over 3. And we have to flip the sign, so it's going to be negative. And that's our new slope. And any lines with those slopes will work. So I could say y equals negative 2 over 3x plus 1, and y equals negative 2 over 3x minus 1. And those should both be perpendicular. And let's take a look to see if that's true. So the original line was y equals 3 over 2 x minus 2. That is our original line. And I'm going to put my two perpendicular lines in. Y equals negative 2 over 3x plus 1, and y equals negative 2 over 3 x minus 1. And you'll see that both of these are perpendicular to the original. They both run at 90 degrees to the original. They just have different intercepts. Right? The intercept's determined by those b values, but the slope of both of them is perpendicular. And again, you could have used any b values here. You don't have to use the two I used. Any b value is okay. And the last question, again, you can try this one on your own, pause the video, and when we come back, of course, if we're going to write an equation of a line that's perpendicular to this, first we need to know the slope. So we need to find m rather. And to do that, we need to manipulate this so it's in the form y equals mx plus b. So we're just going to rearrange it. So 4x minus 6y plus 18 equals 0. We just need to solve this for y. So again, I can hear Krish already yelling at me, saying that I need to get rid of this 4x. So we need to subtract it from this side, and that what I do from one side I need to do to the other. But Bradley's not content with just that, because he says that 18 should go as well. So he says subtract 18 here, and whatever we do to one side we must do to the other. Of course, both Krish and Bradley are right. Those disappear and those disappear. And it should leave us with an x line of what? And now I hear Sam saying negative 6y equals negative 4x minus 18. That's completely correct. And lastly, what should we do? Well, Lexi's telling me we divide this by negative 6. And then before I can even say it, Sammy Sparks is reminding me that division is distributive. It applies to everything on the other side. So do I need to divide negative 4 by negative 6? Yes, I do. And negative 18 by negative 6? Yeah, that as well. So here, these two cancel. That's going to leave me with y equals. But then over here, negative 4 divided by negative 6. Well, two negatives makes a positive. And I could just write that fraction as 4 over 6, but that can be simplified. So I can write this as 2 over 3. Some fractions 4 over 6, it's just simplified. If you'd written 4 over 6, you'd still be right. It just wouldn't be the best possible answer. If you'd written negative 4 over negative 6, you'd still be right. It just would be, again, kind of a messy answer. And negative 18 divided by negative 6, well, two negatives make a positive, I know that. And 18 divided by 6 is, that's right, Jacob, 3. And there we go. So that's the original equation. Now let's keep in mind that we need to make a perpendicular slope. So what is perpendicular to that? Well, perpendicular slopes are negative reciprocals. So if I switch the sign and flip the fraction, it'll become a negative reciprocal. So in this case, 2/3 is going to become negative 3 over 2x. So y equals negative 3 over 2x, and you can pick any b value you want, and you will get a perpendicular line. I'm going to pick plus 1, but you could just as easily have picked anything else you want. That's the worst box anyone could have drawn around something. So this is the perpendicular line. And before I sign off, let's just go into Desmos and just see. Let's make sure that I did this right, and this line is in fact perpendicular to the other. I'm going to write the original equation in, just so that if I screwed up my algebra, we'll see it. So 4x minus 6y plus 18 equals 0. So let's take a look. 4x minus 6y plus 18 equals 0. And that is my original line. You can see it. And my new one, I said, was what? Y equals... By the way, I'm just going to put the rearrangement in. I'm going to put this line in to show you it's the same line, if we've done it right. So y equals 2 over 3x plus 3. And you can see those lines are the same line. All we did was rearrange that. But my new line, my perpendicular one, was y equals negative 3 over 2. So I flipped that fraction and then made it negative x. And I said plus 1, I believe, and there it is. And if you look, those lines are perpendicular. We get a 90-degree angle going between them right here. So that's all. that is the topic of today's lesson. There's a little bit of homework laid out for you on the board, and good luck. I'll remind you, by the way, you guys did a great job yesterday making some posters covering everything we have learned so far. And it's a good idea to go around and take a look at those. They're very well done. Thanks a lot, guys. I'll see you tomorrow.